Welcome to the future of residential home design featuring Dietrich software. This movie was created to show the advanced design capabilities of Dietrich software, focusing on build-up capabilities incorporating energy efficiency software intelligence, 2D to 3D design conversion while working seamlessly inside AutoCAD, powerful user-friendly automated CAD tools, 3D data extraction for material management and design communication, design performance reviews for energy evaluations, and visualization for technical communication, plus how to integrate Dietrich software technology into an actual design project while working directly inside AutoCAD so that both the Dietrich's and AutoCAD software tools can be used simultaneously for a 3D model creation. The movie is broken down into individual sections containing 6 main chapters in which Marcus Brune will demonstrate the entire design process visually, displaying the capabilities of Dietrich software along the way, and the software tools that make Dietrich software the global industry-leading choice for residential home design. The movie is separated into individual sections, so if you do not have time to watch the whole movie at once, you can watch each section individually when time permits. We hope you enjoy the movie as much as we did in creating it. Thanks again for your time, and enjoy the movie.
You know, people often ask about the future of green building, and I have to sort of chuckle. The future of building is green, because if we don't take on a more environmentally responsible approach to the built environment, we're going to continue to take a slippery ride down a very tall slope. For as long as we've been involved in this practice as human beings of constructing and building things, we've looked at the relationship between the built environment and the natural environment as one that is a one-way street. That is, we look at the effect that nature has on the built environment. And so we've always looked at the constructed version of man's activity when we look at materials and we look at where we locate things, whether it's an individual building or a city, an entire nation. We've always looked at it from the standpoint of what effect nature would have on our built environment. Over the last 50 years or so, we've begun to understand that it's a two-way street and that there's a cause and effect, that the built environment actually has a big impact on the natural environment. And that's escalating over time. If we look at our transportation issues, if we look at our resource depletion, if we look at the impact that we're having on all the ecosystems around the world, we can bring many of those things back to the way we construct, the way we design, and the way we plan for the future.
On any design project, there are several key elements that have to be reviewed to make incorporating 3D design tools as seamless as possible. First, what design inputs do we have to work with? No design at all, scanned line drawings, illustrations, or 2D or 3D CAD files. Then we have to find out the construction technology to be used for build-up verification. We have to address scope compliance for the area in order to set the correct construction guidelines. And then we have to review construction site orientation and elevation details in order to make sure the proper flow heights and offsets are used in the 3D design. For this project, we received a very detailed design file that was produced using AutoCAD. The Dietrich software team decided to keep everything inside AutoCAD from a design standpoint to make data sharing simple and reduce the risk of data loss due to incompatible design files. Since Dietrich software is an Autodesk development partner, we have the ability to either operate our software technology as a standalone product using our own proprietary technology, or we can create designs directly inside AutoCAD seamlessly using all the capabilities of Dietrich software technology, as well as being able to use all of the standard AutoCAD design tools for design purposes. This is the best path forward for this project, since multiple companies are involved that use AutoCAD, and the initial designs and vendor files were designed in AutoCAD.
This is going to be a stick-framed wall, so let's just look at the wall properties. These are the properties of a external stick-framed wall. I have a 5.5-inch framing core. Then on the inside I have 1/2-inch gypsum board sheathing and 1/2-inch of plywood on the outside. The total wall buildup is made up out of 15 individual layers. They'll go from -7 on the outside to +7 on the inside. I'll add a couple of vertical battens on the outside here for a ventilated cavity, keep moisture away from the wall. And as a finish, some wood siding, 5 1/8. And just put some values in from the database that explain what those layers actually are, and specify the properties of the layers at the same time. There's external slices, sheathing, and just sheathing boards. With that, we have our wall build-up defined now, and we can look at the thermal performance of that wall. Just click here on U value, and I have a resulting U value of 0.3. The U value is the thermal performance of that wall, and it tells us how much energy is transmitted through the wall. The smaller the U value, the less energy we lose. The current U value of 0.3 is an equivalent to an R19, and it's calculated according to ISO 6946. Here in the center, I have mineral wool mixed with the stick frame with a 16% framing factor. Now to change the U value and edit that, I add some insulation on the outside. That's 3 inches of rigid insulation panels, polyurethane or EPS. And here in the database, material database, I pick out thermal insulation, find the right material I'm going to use. So let's use an EPS panel, EPS polystyrene. And we have the properties of EPS in the database. So if I apply that now, the U value, you see, changed to around about 0.19, and that translates into an R value of R30, which is a much better wall than we had before. With the changes that we just made, we have an overall wall thickness of 11 5/8. If I want to position my wall, I can define a reference axis that I draw, and the reference axis should sum up the outside layers of my wall, so I can define with 5 5/8 the outside of my stick frame. If I draw the wall now, I can either position the reference axis, the outside, inside, or the center of the wall, and trace around the lines that I get from the architect. Now, in addition to that, I can define what information I want to get from my walls later on for costing and quoting. With the tick marks here, I can define from which layers I want to have an area dimension or an insulation dimension takeoff. So for my sheathing boards, the polystyrene panels is insulation. Here I have another area, so I know how much plywood I'm going to need. Same for the gypsum board. C stands for the structural core slice of the wall, and this is going to be untouched by other walls. I can save this setting now, give it a name, and like that, build up a library of walls that I can reuse for other projects. So this is now not US default, this is US with external insulation, ventilation, that's my 1.5 inch battens on the outside, and siding as a finish. Okay, have this wall property saved, and now we can give it a quick test ride. So I go to wall definition now and start to draw a couple of walls that we just did and see how they work. Wall definition, there's my external insulation ventilated siding. It's an external wall. Connect in the corners. I position the reference axis, go from right to left, that's clockwise, belongs to ground floor, and then start to draw the walls from point to point. Now here you can see I'm defining the outside of my timber frame rather than the outside of the wall, and just draw a simple floor plan here. Okay, back to origin. This is already 3D information. So there, take a look at the corners. And here you see the red dotted line is the reference axis, and the gray lines are the individual layers that represent my buildup from inside to outside. tilt that up in 3D. All individual wall objects. And now check the properties of the wall again. Just highlight that one wall. And that's the properties that we defined. So that's the right properties. Okay, and I'll quickly show you what that's going to look like as soon as we apply structure. So that's the overall walls. If I take off the siding on the outside, that's our battens for the ventilation. Next thing would be the insulation panels. That's our EPS. Underneath is the plywood sheathing. Then most important, the actual stick frame. That's our core slice and the gypsum board on the inside. I'll tell you more about structure of the walls and how to apply that in a later chapter. Of course, we have similar properties like the wall properties for floors and ceilings. So here we have different properties that have already been saved for different purposes. Stick framed, concrete, or whatever other style. And we have the same for roof surfaces as well. So there we can set up to 15 layers of roof framing, siding, tiles, or just asphalt. Okay, on this building I preloaded the architect's drawings as external references. So if I just bring in ground floor layout and the sections and elevations with it, so I get an overview of the overall building. That's the sections right there. So I have a good overview and a good idea what the 3D model is supposed to look like. Just zoom in here. So they match up nicely, and I can take my floor heights directly off that section view. So I've started finished floor level. There's 12 foot from floor to floor on the ground floor. And then on the upper floor, it's from floor to ceiling, 9 foot and 1 inches. So I'll set up my stories. That's ground floor number 1. Start the walls with number 1 and have 12 foot to cover. Okay, next floor is new one here. That's my intermediate floor, 1 floor up, 2nd floor here. We'll start again with number 1. Bottom edge is at 12 feet now. And the maximum wall height is the 9 foot 1 inches. Okay, that's my stories created. I go to ground floor, select, and now I'm working on ground floor level. Move that in center. Up here is a drop box. I can switch between ground floor and 2nd floor, but we'll keep working on ground floor for now. So just to verify my wall buildup, I'll take a quick measurement of my wall thickness. Here in the window would be a good point. So just give me a distance dimension on this wall, and this is 6 inches. So I have a 5.5 inch framing layer, and that's exactly the wall property that we prepared earlier. External wall, ventilation, and siding. Here's my wall thickness and the 5.5 inch thickness for the framing layer. I'll position reference axis, connect the walls in the corners, go from right to left, that's clockwise, and then I just draw around the outside perimeter of the architect's drawings. So go from here up to that corner. I position the outside of my stick frame, so this nicely matches up with the architect's idea. Move over to here and go right to there, because here I have a change in the wall thickness, and that's where the architect specified 2x6 studs in the flat stud furring. So we'll have to adjust our wall build-up here. Go back to wall properties and Pick external ventilated siding. And then I add on the inside a service cavity. This is to run the wiring later on, and that's 1.5 inch studs, or actually battens. Go to my batten slices and do horizontal service cavity to run my wiring. Reference axis stays the same. Just save this in case I need it later on. Furring on the inside. Okay. And then I'll just take that new wall property and continue from there. Again, connecting the corners. Reference axis right to left, that's still good. Here I need to make sure it's still set to reference axis, so the walls line up nicely. And there you can see the changed wall thickness works nicely together with the architect's idea. Right to here, and here we change back to the regular wall build-up. In the foyer though, I have a different ceiling height, different room height. So if I look at my elevation, you can see that the walls start higher up. So let's just find out how much that is. Go from here to there, that's 11 inches exactly. So when I draw my new walls here, I just start them at a different level. Bottom edge is at 11 inches now. And I'll take those 11 inches off the total wall height, so they're flush at the top. 11 foot and 1 inch. Good. Continue from there. Again along the outside. And here in the corner it didn't connect automatically, so I'll fix that up quickly. Go to make a corner connection between this and that wall. Done. And here we carry on as before. Oh, there's another step in the height. So that's at a new height level. Going from datum point to vertically up here, 1 foot 10 inches. So it's really good to have the sections and the floor plan together. Okay, wall definition, adjust the bottom edge. 1 foot 10 inch. And again, we take that off the total height of the wall. That's at 10 foot 2 inches now. Okay. And just carry on as before. Around the office part of that building. Go to here. And past here. No, wait, that was too far. I've run past the garage here, so I'll quickly throw this one wall out. Delete this. Go back to my wall definition. Last values are still in the dialog box. And it goes to here and around the front of the garage. Back to here. And this is where the height level is going to change again. So quick look at my section. See, there's the height level. Need to be careful about that. So that goes just back to 0 and a 12 foot total wall height. And then I'm about ready to close the outside perimeter of our building around the fireplace and all the way back to here. So from here I have my outside walls drawn out. I'll quickly show that in 3D. Oh, there's one corner to fix, sorry. From here to there. Okay, check. Okay, that level looks good. turn it up into 3D. You can see the floor plan still sitting there in 2D at the bottom of the floor level. And I'll quickly go to a different visual style so you can see the walls better. Do them shaded. And that's my external walls. So there's an elevation view. Back to 3D. Maybe have a look at the different visual style yet. There's ground floor, wall number 18. Okay. Quickly go to transparent. So you have multiple visual styles that you can pick from, whatever works best for the design. And up here, just zoom in on that wall, I'll have a window that I have to insert. So go to square windows here. I'll insert it into this wall. And that's my kitchen window. Wood painted with a high transom. Casement window. You can see the transom here. There's the U value for my window, so the energy performance, same as the wall, and the solar energy transmittance, that's 70% of the solar energy make it through the glass. Rough opening is 9 foot 4 inches wide and 5 feet high. Sill height is 4 foot 2 inches, which leaves us at the top height of the window at 9 foot 2. And I offset the window from the outside of the wall by 2 5/8. Structure. This is just for visual representation. I have a tilt and turn window specified here. This one opens to the outside though, so it's just a turn, hinges on the left side. Second pane and third pane is also just a turn window, hinge on the right. I'll grab the center of that window and drop it right there where the architect specified. I could still move it left and right if I needed to, but just drop it at 0. And here you can see the window in 3D. So I'll make that a little bit shorter and show you the completed ground floor plan. So there's internal walls that I added. Look at that in transparent view. So I have doors and windows in here, internal walls, garage door. Look at the whole thing from top. You see how it matches up with the architect's drawings. I have a couple of double walls where the architect specified bigger walls. And if I go and switch to second floor, I already drawn that out as well. Just show you second floor here. Again, external walls, internal walls, doors and windows. Very similar process to what I've shown you before. All right, I have a total building model now in here. So if I just switch on the walls from ground floor in my display filter, you can see the different story heights and how it actually goes together. So you can exactly see if walls line up from ground floor to the upper floor. So now we have our walls completed. And we can move on and put the roof on. For that, I switch to roof calculation. And first off, I have to define the footprint of my roof. The most simple thing is to just take ground floor or intermediate floor here, copy the reference axis. I can also do a graphical input or use any of the prepared shapes. So here I just have my footprint of the roof taken off the reference axes of the walls. I'll have to adjust a couple of things. So here, over the balcony, the roof will have to come out by another 7 feet. Go to Edit Roof and move this line. It's line number 5. And move it out by 7 feet. Okay. That should be about it, and we can go and calculate the roof shape. So go back to roof calculation. I take all outlines now. Add my roof properties. I will use a simple roof here. Roof slope has a rise of 3 inches over 12 inches. Overhang is 2 foot. And the eaves height I quickly determine. Here I have my rafter configuration, and this is the perpendicular distance over the bird's mouth. Okay, that's the total eaves height that it comes out to. Eaves height is out here on the rafter, top edge. And it will calculate the roof shape with ridge lines, hips, and valleys automatically for me. This is in 3D, second floor walls, and the roof together. Over here I need to adjust because I don't want those hips and valleys. I want that just to be one continuous roof surface. So I'll have to adjust number 20 and 2. That's not roof surfaces there. They just go to no properties and 90 degrees. The overhang I keep though, and the eaves height is irrelevant. And on side number 1, I'll reference that back to side number 19. So this will be one flush continuous roof surface. Software works out the eaves height automatically. And you can see now how this changed into one roof slope, and it just took the eaves height down. Okay. So I'll make that a little bit more visual and add the roof panels from the properties. Okay. So there you can see the roof finish, transparent view, and you can see the entire roof landscape there.
Houses are complicated, designs are complicated, and there's a lot of different materials and large quantities and sometimes small quantities of different materials that go into a house. So the old days where you could do a rule of thumb and do a calculation as to how much lumber to order, or the old days when you had a den that was 10 feet by 10 feet and you put 12-inch square tile in there, those days are long gone. So you need a software like Dietrich's that can keep up with the design advancements and the product specifications that are going into today's home. So with Dietrich's, at the click of a mouse, your architect can kick out your quantity takeoffs of different materials. And if the client says, you know, I don't know if I want a cobblestone pattern versus a herringbone pattern, your architect, the designer behind the Dietrich software, can click out both options for you, give you an immediate calculation as to what those quantity differences will be in the same space, which enables you to, in real time, present to the client, at least at a minimum, the cost and material quantity impacts of those two different decisions. That could be inside the house or that could be outside the house. A client that says, I'm thinking about a wood siding or perhaps a stone veneer, maybe a composition shingle roof or a clay tile roof. With a software like Dietrich's, you can do those calculations immediately and know the real-time cost difference between those selections.
Apart from the build-up and the material specs, the wall property is already linked with a parametric guideline that defines what kind of structure this wall is going to be. So that's my wall construction guideline right there. Here I have a couple of different guidelines again in a library that I can select, but this one will do for this wall build-up. And with that guideline now, I can just go to construct the wall, select the walls I want to have done. And the parametric guideline will just add the stick framing, the details, and the sheathing for me. Keep the wall properties the same. And you can watch the guideline applying all the settings. And here you can already see the framing in a transparent view. I'll quickly go to the display filter and reduce that just to show group 0, which is the framing. And there you can see the individual lintels, studs, the header detail. So now I can isolate one individual wall. Go to ground floor, find the wall we've just been working on. That's number 9 here. And this will isolate that one wall, show me an elevation and a section view. And I can start to edit the window. Now this will show you the power of the parametric guideline, because if I just go into systems for the window and select a different lintel detail, a header. So I have a couple of header details in here. Go to my 2x8 double header. Okay. And position the window again. And all I have to do now is just rebuild that wall. Go to systems. Get this ribbon out here because I'll need it again. And go construct this wall. Same routine as before. Keep the wall properties. This will rebuild the structure from scratch. And I have a entirely different header detail applied. So if I turn that into a 3D view here, can get a better shot at the header detail. That's double headers here. So like that I can just pick out the detail I want to have for this cause. So just to show you another change, I'll change the size of the window now. Go back to the window, go to the rough opening, and just make it wider. Go from 6 feet 2 inches to 8 feet 3 inches. You can see the preview changing right away. Okay, I'll grab the center of the window to keep that in the same place and position it right where the original window was. So now you can see how the window size changed. The structure didn't follow yet. And again, I just hit the construct button. Okay, keep the wall properties, and that will again reconstruct. So there's a very fast way of parametrically changing things, editing windows, like things that normally happen on site. Client wants a different window, and with a couple mouse clicks, that's edited. Of course, we have the entire wall build up in here, so I just go and show you the plywood with it. Go to a different visual style here, so it's easier to see. Go to textures, so that we have the plywood on the outside, individual sheets, inside the stick frame. Then go back to my display filter. So then we have the insulation. That's my EPS panels. So the total structure of the wall with all materials, everything is included. Also on the inside, my gypsum board is right there. Header for the floor joist is already there. If I go back to the floor plan now, I can show you why it is essential to have a 3D model. I'm just going to bring in the floor plan from the architect again. And over here in the great room, there's a couple of big floor joists. Those are going to be visible afterwards. And they're bearing on 2 walls. And on this wall here, we have a huge, big opening, bifold doors. Very nice, but our floor joists have nothing to bear on. So if I go back to wall design of that wall, You can see the floor joist here sitting on top of the wall. And there's not an awful lot of support. That double header is probably not going to do it. So instead of taking the guideline and letting it run over again, I'll just show you a graphic change here and delete all those components that I don't need. So the header detail, the posts and the cribble studs. And those need to go as well. And I'll manually add the components that I need. So I'll need vertical beams, general post, and this is not going to be a 2x6. This is going to be substantially bigger. So I go back to 4x6 here and place a single one on either side of the opening. Okay. Then I'll need 2 regular studs, 2x6, right next to the posts. The post I need to cut back to the top edge of the opening, so I'll quickly show the top edge of the opening permanently here and cut them off at exactly that level. This end goes away. So now I have a big room up here where I can put a header detail in, horizontal beam, and this is not going to be structural timber. I go back to my material database and I can find the right material for that job. So this could be, for example, a wide flange steel beam that could carry all those loads. But since I want to stick with a timber design, I go to laminated timbers and find a good glue lam that will also do the same job and still be sustainable material. So there's a 3-foot length, 5.5 inches wide, and the height I'll take directly from the model to fill that gap entirely, because I need to custom order that piece anyways. It could just as well fit the space. So that's 1 foot 3 5/8. And put a single piece in there. It starts with a 3-foot piece and then it stretches to find the next available timber to connect to. And on the right hand side you can see how it put that header detail in. So that's, you can see it on the texture, it's a laminated beam, and that should take care of the loads coming from the floor joists and will carry the walls above.
I think it's important that people have an understanding of what their competition is. And in Southern California, in the LA area on the west side, there are a lot of custom home builders. And so what we think is a big differentiator for Structure Home is the ability to use a software program like Dietrich. We think Dietrich really gives us a leg up on the other custom home builders in the Los Angeles market because of its capabilities.
Now that we have the 3D model, we can start to focus on what information we will need to extract from the model for business and building project management purposes. All of this information will be taken directly from the 3D model that we created. No other source is needed for additional building and performance data purposes.
Now we'll look at the results from our 3D model, and that's bill of materials and sizes. Before we do any lists, we'll have to run through the sorting and labeling routine. The sorting and labeling routine will identify identical objects and give them the same number. So that's my sort and match setting here. I start with object number 1 and run my sorting through either the entire position. I can also start for every floor or for every wall with number 1. We'll just go for the entire building and then look for identical pieces either in the entire position, inside one floor, or for one wall. So I want to start and sort according to story and also identify packages and elements. And that will now run through and give every object a label that makes it easier to identify later on the lists and on the shop drawings. So now that the sorting is done, we can generate the first results. And I'll move up here and make a material list. So there's different types of lists I can generate from here, either material lists, dimension takeoffs, and windows and doors. We'll go to the material list first. That's my bill of materials. And here I can select what I want to take in consideration, the entire building or just one story. Then I want to have a list for my timbers, for my stick frame, and for the sheet material for my plywood, insulation, and the gypsum board. Profile beams would be I-joists or metal connectors, fixtures, but those two should do for now. All that is written into an Access database, and the project data program is the front end for that database where I can manipulate the data, look at it, and print different things. So here's my timber list and my sheet material list. We'll have a quick look at the timber list. So go edit. And that's the timber list for that building. So here I have ground floor, stud, and the material taken from the database. If I look at the database, I can specify different materials. Here I have spruce pine fir, grade 2 or better, with an order number depending on my supplier, color set, and price per unit. Unit is board foot. Any additional information that goes into that, and all that comes with that number. Here's my sorting number. That's what the labeling routine applied to every piece. And that's 2 pieces, 4 pieces here, 1.5 by 5.5 inches, 2 by 6, and the total length. So that covers my entire building. All the stick frame components are listed in here. From there, I can export that to Microsoft Excel, for example. And that opens directly in Excel. And I can start calculating things in Excel, doing my spreadsheets and all that. So that's a lot of information in that spreadsheet here. Okay, if I close Excel, I can go back to here. And of course I can print lists directly from the project data program. So for different purposes, I can take different templates. Just go to output, and I just want to have a regular order list on a letter format, and either Microsoft OpenOffice or PDF. Currency is dollars. I can insert my own address, customer address, suppliers, any additional text information, and just click the button, and that goes directly into a PDF document that I can email to my supplier, set it up with my letterhead, and have all that information on a nice template here. Okay, now we close that PDF again and go back to the 3D model. Now, additional information about my walls is dimension takeoff. Before, in the wall properties, I've set up what information I want to have on my walls, and now I'm going to take that off the 3D model and put it into the database. I do that either just one floor or the entire position, subtract openings, and I do all the walls. Okay, and that will put information into the Access database that again I handle with the project data program. Now on the dimension takeoff side here on the right, I have my exterior walls, interior walls. This is exterior walls for B12. That's the ventilated siding, the furring walls, plaster walls. If I just look at the external walls here, that's 27 walls total, 450 feet. total outdoor area of 3,500 and something square foot, and that broken down per wall with the openings. So that's my garage door, window openings, French doors. So you have the control pictures there to show what openings have been taken out, and some openings are small enough so they're not taken into consideration for the costing and quoting. They're just over measured. Okay. Now I can split the walls up into the individual slices. That's what my tick marks on the wall buildups did. And here I have sheathing boards on the outside with the total area. True slice area will take all the openings out, independent of size. Then I have gypsum board on the inside, plywood. The true slice area of the plywood is going to be less than on the sheathing boards because it's further inside the wall. And the gypsum board on the very inside is going to be even less because it's the inside area. Because of all the corners, this is less than the outside. So I have an exact overview on the amount of material that I'm going to need to build those walls. Expanded polystyrene and mineral wool, I have insulation takeoffs. So especially for the mineral wool, because that's in the same layer as the timbers, the stick frame is already taken out, and I have the exact square foot amount of my bats that I'm going to need. Or if I do spray-in foam or blow-in insulation, cellulose fiber, I also have the cubic foot value for that. That was the dimension takeoff. I go back to my 3D model. And we still need to do windows and doors, the schedules for that, so we can order that material. Go back to my results, lists, window and door list is what I want to have. For all walls, just for one floor, just for one wall. Okay. Again, information goes into the database. Go back to project data program. And I have the window and door list on the material side. I'm going to print that right away. This time, we're not going to do a PDF. We put that right into Microsoft Word. Currency is set to US dollars. And that goes into my Word template. And I have my window schedule with the descriptions, the sizes in my Word document, and I can edit here, print, email directly to the supplier. Okay, I'll show you where that information on the windows actually came from. Just zoom in on that window here. That was the one we put in the model. Go to edit. And the information on the list, you'll find on information attached to every window. So that's the kitchen window with the U value, G value, and the window number. Okay, back to the floor plan. And we're going to do a couple of 2D drawings now. So in-ground plan, I can do floor drawings, wall drawings. We'll do the floor drawings right now. I'll store and insert the 2D drawings right next to the 3D model. And here I can define the content of my floor plans. I want to have 2 floors, ground floor and 1 floor up, second floor. Over here, my unit system, I set up what units I want to use. Here define the dimensions. I dimension my outside walls. And for the openings, I give a center dimension and all that in architectural dimension style. So there's my 2D drawing. I just grab that here at the corner and put it right next to the 3D model. Drop it there, text box, and that's my second floor here at the corner, and move that up here in that area. Text box for that. Okay, this is all 2D drawings now, taken directly off the 3D model. So you can see the dimension lines, window sizes, all automatically dimensioned to my specifications. Just regenerate to make the curves a little bit nicer. Zoom back out. And up here, my second floor, same thing, automatic dimensions created. And if I rotate that up into 3D, you can actually see that this is just 2D drawing objects generated directly off the 3D model. And the 3D model still is there. Okay. Back to top view. The 2D drawing blocks stay connected to the 3D model, so if I need to make any changes, I make the change on the 3D model, and for example move that wall here out by 3 feet. Okay, so the other two walls stretch automatically, and my drawing blocks don't show that change yet, so that's a recalculation. All my floor plans need to be recalculated, and you can see how it automatically adds the dimensions, moves the wall out to match up with the 3D drawing again. So from here we'll move to sections and elevations to show some more detail. Sections and elevations are defined here. The front, back, left and right elevations are there automatically, and I can just pick one and turn that into a hidden view. So here I have my structural components, my doors and windows in a section view up to the roof, and I'll turn that into a sectional drawing, which again I'm going to put right next to my 3D model. Define the content here, what kinds of dimensions I want to have, representation and labeling, very similar to the floor plan. Okay, that turns it into a 2D block, and I can just grab that at the corner and put it on the right side of my 3D model. Put that here, text box. Okay, now you can see the dimension lines that have been created automatically, and I have another section that I positioned down here that goes lengthwise through the building, shows all my I-joists over the garage, connections to internal walls, external walls, my big glue lamp here over the window, and that should do for my drawings. There's the great room again, garage, my office section. I can edit all that. That's all 2D AutoCAD entities, so I can move text around, change lines, change dimension style. So all that looks good to me for now. The floor up here, nothing that overwrites. Okay, that should be good to go. Now the next drawings I'm gonna generate is elevations of each individual wall. Actual framing drawings for the guys inside to frame the walls up. So I do that in wall design here, where I isolate individual walls. And from there I can generate wall drawings right away. Those are not going to be next to the 3D model. Those go into a separate DWG. So I just pick a template and generate a new drawing file. That's going to be a lot of walls. That's my wall framing drawings, just simple framing. Calculate hidden lines, show a story overview so I know what wall I'm looking at. I want to have labels for my windows and doors. Objects labels, I just want to have the sorting number for the framing layer, so I can reference it back to my lists. Dimensions, and I insert a timber list right next with the drawing. and let it run. And that's going to generate a separate DWG, which I can bring up from the project management right here. So here I have the drawings, ground floor wall, and this is my actual building model. And if I open that up, that's a DWG, opens in AutoCAD. And there I have all the walls side by side, fully dimensioned. So now you understand why I didn't want to put that right next to the 3D model. Here I have wall number 9. That's the wall I'm looking at from the outside. So it keeps it easy overview here. I have a horizontal section through the wall, a vertical section there. Here I have the elevation of the wall, some text that I need to move out a little bit, so it's better to see. That's window number 8 sitting in there. All of that is, again, regular AutoCAD 2D drawing objects that I can edit with the same AutoCAD functions. Over here is my timber list, and that's the sorting numbers and the length of the object. So number 463 is 10 feet 5 inches long, and I can find that on the drawing. Same here. The windows, so I can reference them back to my window list. That's my flat fooring walls. You can see the buttons running there. And that's my wall drawings. Just put them on layouts and they're good to go. Move that over here a little bit, stretch it out. And that's a whole lot of walls, all done automatically. And ready to be printed and go out on site. Now let's take a look at the thermal performance of our 3D model. Let me show you again the wall properties. Every wall has a U value that's calculated by the layer buildup and the materials that are assigned. The U value of this wall is 0.3, which is an R19 wall. The U value is calculated according to ISO code 6946. Here I have mineral wool together with my stick frame, and that's the heat conductivity for that. So that's the thermal performance of my walls. Over here we have a different wall that has more insulation on the outside. We'll take a look at the properties of that. So here we have an external 2 inches of expanded polystyrene, and the U value is 0.21, which is an R of 27. Slightly more energy efficient wall. And the same U value is also assigned to doors and windows, to the openings. Here we have the U value 1.2 and the G value for energy transmittance, solar energy, that comes in through the window. For the energy calculation of that building, we need to define individual rooms and zones that have different conditioning, different heat. So I'll just create a couple of rooms. Actually, I already did that. I'll just put them in from the display filter. Now you can see the individual rooms, foyer here, the kitchen, great room. That's all in 2D. But there's also a 3-dimensional side to it that gives me the air volume of each individual room. And together with the air volume, the energy that's heated, that's stored inside that volume. So that's the blocks that represent the volume of each room. There's the staircase winding up, so that goes up to second floor level. Over here, garage, office, all individual volumes, so I know exactly how many cubic foot of air have to be heated. Okay, bring the model back on and go back to a plan view. Okay, bring the room information back quickly. Display filter. There we go. And now I have to categorize every room according to its energy performance. So this is a residential building, and here I have heated or non-heated rooms. And I can just assign rooms to be heated or non-heated. Just click at the boxes. That's the great room, the kitchen, the butler's pantry, dining room, stair hall, pantry. Like that, I just go through the entire building, go to the next floor, and assign what rooms are heated or non-heated. Residential, non-residential makes a big difference because residential buildings usually are one zone, and non-residential have individual zones with different temperature levels. Now, the model that we have here, we transfer all that information into a GBXML format. Transfer the building. And first of all, we compile all the information and show that on the screen. So I'll go through step by step. This is the zones, the heated areas of my building. So you can see the red, the garage is missing, is not heated. That's the construction footprint. That's the walls for first and second floor and the roof areas. So you can see how the individual zones are split up and the walls are considered heated space. There's the net ground area where all the walls are taken out. Also that information is necessary for the GBXML file. The grow area, that pretty much represents the entire area of the heated volume, the footprint. Then we come back to the room volumes. That's the airspace used by first and second floor, without the walls and with the walls. So depending on construction. Then we have our thermal envelope. Here's the foundation bits and pieces coming together to an entire concrete slab. Then we have the ceilings limiting the building to the top. Again, every room has its own heated ceiling. There's the staircase. We have a big gap in the ceiling. And then we have walls for first and second floor. Every wall per room spelled out individually with the openings, doors and windows. And to every of those components, there's a U value and a heat level for the room behind it. So all that together is my thermal envelope. There's the roof surfaces covering the rest of the building. And that is the envelope that's going to transmit heat to the outside. So this detailed description of the thermal envelope with all the areas and the thermal properties of walls, ceilings and roofs, we generate a green building XML file, which we can then use to generate certificates for different code requirements for HERS, net zero home, or even for a passive house.
Another thing that comes up often is people want to know what direction codes and regulations are going and how we can employ modern tools to deal with these issues. So let's think about the origin of building codes, for example. And they came out of a need to assure life and safety. They came out of the need to have engineering predictability in the buildings that we built because they became taller and bigger and more dangerous in some ways. And they would house more people and take up more resources. What we see in the future is a continuation of those kinds of issues, but beyond that, we're going to have to also deal with a predictable performance of buildings. So in the use of energy, in the way we treat indoor environment quality, including the air, in the emissions that are caused through that whole process, in the water resource, and in the way we handle the life cycle of all the things that we use to construct buildings and develop cities and all of the things that are involved in that. So tools that are really necessary for the future of the built environment that will help designers and engineers and builders to give us results that we can depend on and that will have less negative impact on the natural world, like Dietrich software, for example, gives us the ability to assure the performance of the built environment, and not just from a safety standpoint, but in all of the ongoing operation and occupancy of buildings.
Clients today have an expectation, as they should, that their home is going to be the best possible performing home on the market. And they want options, they should expect choices, and we try to give them those choices. So when you're evaluating a window selection or perhaps an insulation specification, and you're discussing those pros and cons with the client, they want to know what the performance difference is between, let's say, a BATS insulation or an open cell spray foam, or when you get technical with a client, you talk to them about a U value rating on this window that's double pane versus a triple pane window that has this U value. Clients get confused real quick. So when you have a software like Dietrich's, it can really break that down into energy modeling or performance analysis that the client can understand. So you can show them a model of a home that has a baseline specification with this type of window and this type of insulation, and then you can give them the option of an upgraded window or an upgraded insulation package, and then lay out to them in plain terms what that performance difference will be. That's the beauty of Dietrich's.
Since we're now in the final phase of this design project, we will finish the 3D model by incorporating photorealistic rendering techniques for technical communication purposes. These types of renderings can be used for marketing and sales purposes, general customer communication, or communications to vendors and subcontractors. The reason is very simple why these types of visualization tools are so powerful, because a picture tells 1,000 words, and this type of communication really emphasizes the details of any project and adds a tremendous value in time savings, but make it easy to show exactly how everything should look in 3D.
Now we have the 3D model finished, and we'll look at rendering capabilities first inside AutoCAD. So I can change the visual style, as you've seen before. There's a couple of different styles that come with it, and there's a couple one that we prepared. So this will be a shaded view, where I have my surfaces shaded in color. Can look at elevations, that's pretty good for that. I can use that to render, set the light source, or just take the sun status. Depending on the location where I'm at, it shows different shadows for different times of the day. The location can be specified here either from the map or from a file, and you can set the date and time of the day. I can create cameras and use AutoCAD to render it inside AutoCAD or render it in the cloud online, which goes a lot faster with more computing power, and have a render gallery for every project. So that will just upload to Autodesk 360 and use their render capabilities. That's the rendering inside AutoCAD. And we go to a different visual style now. Turn the shadows off. Rotate the model around. And the nice thing about the database is every material has its own texture that comes with it. So if I go to realistic, I right away have different textures for plaster or siding. In this case, a brick veneer, siding, different wood species. So you can see the OSB and here spruce studs. And if I go and change one of those posts, every object has its own object information. Go just for one object and take the post on the corner here. So there you can see the texture set that's spruce right now. And if I set that to laminated timber, construction wood, oak, larch, any other wood species, beech, pine, Pine's okay for that. And you can see right away how the texture changes the object. So I already have fairly realistic textures to work with and render my 3D objects. The normal work environment in AutoCAD is we have a parallel perspective, so all the parallel lines show up as really being parallel. I can also switch that for a more realistic view, and it goes to a central perspective. So that goes from parallel to perspective here. I have a horizon that gives me an idea where the building is in space, and that already looks a bit more realistic than before. Instead of AutoCAD, we can of course export to different file formats. So for this 3D model, I take something that's very common. I just export it to SketchUp. So we have export here, different formats, and we just take a SketchUp export, which will open it directly inside SketchUp. There's another sorting routine. A couple of objects did not have a label. Okay. So I'm going to export that to a SketchUp template. Take minor holes out to make it easier on the computer to calculate. And just hit OK, and that will open directly inside of SketchUp. So this is SketchUp, and I have the same 3D model that I had in AutoCAD with the same textures, all transferred, individual volumes. And yeah, from SketchUp, the world is pretty much open. So there's rendering capabilities inside SketchUp that are very interesting, and I can still add furniture and things in here. So we organize that in building elements. So if I just take the roof off and show you top floor here, take the ceiling panels off, so you can actually look inside top floor. This is also good for the client to play around with it. Everybody can download SketchUp from the internet and just have a walk through their new home to be. I can start to put furniture inside. We have it organized in a building structure. So that's the roof taken off. I can take entire top floor, just hide that. And in ground floor, take the ceiling panels off so I can look inside. Can bring individual ceiling panels back in for different ceilings. Let's hide those again. Okay. Structural objects, wall objects, and object visualization. So if I take the wall objects off, I'll be able to actually see the structure. The structure is organized by AutoCAD layers. So if I bring up the layers, I have the same layers that we had in our 3D model in AutoCAD. So 20 is the room volumes. I have outside layers, bring that all on, and then show you the structure step by step. So -7 would be my brick veneer. And then we go from outside to inside. -6 is the siding. -5 will hide -4. Then -3 is the insulation panels. -2 takes off the sheeting on the inside, and -2 on the plywood on the outside walls. And now I have just the stick frame and my inside gypsum boards left. Zoom in on that area here where we put that big glue lamp on top of the window, get the window objects out of the way. So this is also a way to communicate with technical people and show them certain areas of the building, highlight details. Now let's roll back to the original model and brush this up and make it look nice. So I add a front garden, just a couple of things that I took from the internet, bushes and grass. Okay, move that in place. Then this shows the rest of the plot of the building. And move over here. We Have to add a nice wrought iron gate. All things that are free for download within SketchUp, which makes it really interesting. Add a car. And then the railing for the balcony up there. Okay, that's the railing. And if I switch to scene number 2, where I prepared a view with the shadow, you already see that it's getting a little bit more realistic. I can turn the shade settings, shadow settings on and off, define the time of the year. Again, set the location in Google Maps. And from there, with rendering software, we can just make that really shine, have a ray tracer, the car reflects, then take Google Street View and actually put that house in the place where it should be. And right there is a rendering of the bedroom. You can see the light on the outside, the internal light sources, rendering of the TV. So that's the pictures that should really be able to sell the project to the end client.
The interesting thing about all the tools that we see being developed today that help designers and engineers and builders to construct is that they blend all of the necessary elements that we've talked about. And what they do is they provide us a template going forward that we can use to accept new technologies that emerge and new building materials, new ways of designing, new ways of interpreting space, locations, because as we know, there are areas that we occupy now that may not be occupiable into the foreseeable future. And so as we continue to evolve our built environment, these tools are going to be absolutely necessary in order to give the level of assurance that we need to have the safe and well-performing built environment going into the next century.
Structure Homes is an organization. We build about 10 to 15 custom homes every year. We're a design build firm. And we take a lot of clients through that design build process. And we have realized that a lot of clients, when we're going through it, look at 2D plans and they don't really have an understanding or really good feel for the spaces. So trying to design a dream home for a client without them really having an understanding of what the spaces look like, how the rooms unfold, is until it's built has created some challenges. With the Dietrich software, we realized to have 3D capabilities is really a wonderful tool. So we can design homes with our clients and they can literally walk through the spaces and they can see the spaces in a three-dimensional manner, which really helps guide them and allow them to have a better understanding for what the space feels like and how the home is going to ultimately live. If we can do that in the design stage and correct a lot of those issues or concerns up front, it saves a lot of time, it saves a lot of money, and I think it's a wonderful process. It's a wonderful development to use the new technology, and to see plans develop in 3 dimensions is a great tool for us.
Let's talk about the return on investment for Dietrich software and how quickly the product can pay for itself and become a very productive software design tool for builders, architects, and construction professionals. Dietrich's software 3D model includes volumes of critical information that is not included when designing with AutoCAD Lite, standard AutoCAD, or other 3D-CAD design packages. Information like wall, ceiling, and roof buildups, all designed with the exact materials along with their material properties. Defined construction parameters, so all design features meet building code requirements. Accurate material information down to the nail for material management and material utilization purposes, waste reduction, and costing evaluations. Total design performance information, including ISO 6946 traceable U values and automatic 3D volumetric calculations, both needed for GB/XML formats and 3D model performance evaluations. Automatic 3D to 2D dimension drawings for building contractor and vendor communications. photorealistic rendering capabilities for increased marketing exposure, which can lead to decreased sales cycle times, so more homes can be designed and sold in less time. Even though all of this information is included in a Dietrich's 3D model, the software can still deliver a 50 to 80% reduction in overall design time over traditional CAD design methods. Dietrich software populates each model with critical data elements that can be extracted at any time, so the designer does not have to spend valuable time calculating or drawing these types of design elements manually. Dietrich software can save the building professional hundreds of hours in overall design time, saving tens of thousands of dollars in design time reduction, as well as additional fees that come from architectural design consulting, third-party performance evaluation companies, and engineering firms. When you add all these costs together and you compare them to the initial investment of Dietrich software, the product can pay for itself with the successful completion of just one project. Do your business a favor by investing in a seat of Dietrich software and give your business the technological advantage it needs to be successful against the competition.
So the software that we use represents technology to our customers, the latest and greatest, including software like Dietrich's that has the ability to do the estimating, the material takeoffs and the cost calculations, the energy modeling, as well as the 3D walkthroughs of the home so the client has an idea of what it will look like before the home is built.
As we experience more extreme weather, we're going to have to develop more viable strategies for dealing with things like drought, wildfire, superstorms, floods, tornadoes, and hurricanes, as well as our diminishing resources, particularly as it relates to energy, water, and natural materials. So all of this is leading for a growing need to have a smarter built environment with intelligent products and software tools like Dietrich's that help us understand how we optimize our resources, our energy efficiency, and to create better spaces in which we can work and live and play. We need to promote intelligent living, and software products like Dietrich's will help us do that.
Dietrich software technology is one of the tools we're going to utilize to stay ahead of our competition in a hyper-competitive luxury custom home building market today.
Thank you again for watching. We know your time is important, and we greatly appreciate you taking the time to review the future of residential home design featuring Dietrich software. I hope that you enjoyed watching the full capabilities of Dietrich software and how Dietrich's technology has the ability to provide build-up capabilities incorporating energy efficiency software intelligence, 2D to 3D design conversion while working seamlessly inside AutoCAD, powerful user-friendly automated CAD tools, 3D data extraction for material management and design communication, design performance reviews for energy evaluation, and visualization for technical communication. Dietrich software is your solution for residential home design and wood construction, and it is the only software package you will need for designing even the most complex 3D models from start to finish. If you would like further information about Dietrich software, please visit our website at dietrichs.com. Thanks again, and we look forward to hearing from you and finding out how we may assist you on your next design project.